So good morning my dear students. So today I am going to discuss mathematical reasoning. So it is from this topic we will get one question in JEE mains. Okay, and it is the most easiest topic. Okay, so now I am going to discuss some key points in this. Okay, so the key points is, the first key point is statement, mathematical statement. So when we say that mathematically a sentence is a statement, it should be either true or false. It is either always true or always false. Then only that sentence becomes mathematically it is a statement. For example, 2 plus 2 is equal to 4. 2 plus 2 is equal to 4. So 2 plus 2 is equal to 4, which is always true. So 2 plus 2 is equal to 4 is a statement. 2 plus 2 is equal to 4. It is a statement. And next, if I take one more example, 2 into 3 is equal to 5. It is always false. It is always false. So it is also a statement. So 2 plus 2 is equal to 4. It is always true. So the truth value of this statement, is denoted by T, because it is true. Next, the 2 into 3 is equal to 5. It is always false. So it is also a statement. And what is the truth value of this statement? False. It is false. It is true. Okay. So if the statement is true, then the truth value is denoted by capital T. If the statement is false, the truth value is denoted by capital F. Suppose if I consider today is a Thursday. Today is Thursday. So today is a Thursday. So there will be some confusion. So today means what? With what reference you are taking? Today is a Thursday. If it is yesterday is Wednesday, then today is a Thursday sentence is correct. If yesterday is not Wednesday, so today is Thursday is wrong. So if I take today is a Thursday, that sentence, it is not a statement. It is only a sentence. It is not at all a statement. Okay. Next, I am going to discuss logical connectives. Logical connectives. So, logical connectives. So in this topic, logical connectives, there are 5 different types of logical connectives are there. The first one is, it is called disjunction or OR. And next, conjunction. And or it is called AND. Next, negation. Or it is also called NOT. Next, if then. If then. Next, if and only if. If and only if. So in this topic, we are learning these 5 logical connectives. So the conjunction of two statements is denoted by this PRQ. The disjunction of the statements is denoted by PRQ. Disjunction of P and Q is denoted by PRQ. And how to read? PRQ. And conjunction or AND. So the conjunction of two statements is denoted by P and Q. And the conditional of P and Q is denoted by this P implies Q, or if P then Q. And the biconditional of P and Q is denoted by P biconditional Q, or P by implies Q. Okay, or P if and only if Q. Next, negation of P is denoted by this. Okay, and truth table. So before that, we have to discuss one more definition: compound statement. Compound statement. So a compound statement, a compound statement definition nothing but it is the combination of some simple statements. and they are connected by one of these, at least one of these logical connectives. So that means when we say that a statement is a compound statement, it is a statement which contains at least one of these logical connectives. So next, truth tables. So truth tables for these logical connectives. So this is P or Q, or we call what? Disjunction of P and Q. And this is P and Q, or it is nothing but conjunction of P and Q. This is the conditional of P and Q, or if P then Q. And in this P, if P then Q, P is nothing but antecedent, Q is nothing but consequent. So P is nothing but antecedent, antecedent nothing but given statement. So Q is nothing but consequent, consequent is nothing but conclusion. Next, P by conditional Q. Next, negation of P. So negation of P means nothing but opposite meaning, opposite meaning. So sometimes in mathematics we need to find opposite meaning of the given statement. For example, 2 plus 2 is equal to 4 is the given statement. So what is its negation means 2 plus 2 not equal to 4. Next, one more example. Suppose x is an integer. X is an integer is the given statement. So what is its negation? X is not an integer. X is not an integer. Okay. Next. So now the truth tables. How to remember truth tables? So suppose if we have two statements, if we have two given statements, then what are the possibilities or what are the combination of their truth values? Either both are true, or first true, second false, or first false, second true, or both are false. These are the four combinations, or these are the four possibilities of truth values of given two statements, say P and Q. So here P and Q are some simple statements. Simple statements means the statements which do not contain any logical connective like or, and, if, then, if and only if, and negation or not. Okay. So how to remember these truth tables? So for every this connective we have one key point. So for R one key point, for and one key point, for implies, by implies and negation one key point is there. Just you remember that key point, no need to by heart this. So in R, what is the key point? Means if both components here P, in P or Q, it is the compound statement. In this compound statements, what are the components? P, A, also Q. So if both are false, if both P and Q are false, then only it is false. Then only P or Q is false. So that's why I'm keeping here some star. So if I remember this, then I can write this truth table of P or Q. If both components are false, then only P or Q is false. Remaining cases, true. Next, and if both components P and Q are true, then only the compound statement P and Q is true. Remaining cases, false. So in and, what is the rule? If both components are true, then only P and Q is true. Remaining cases, false. Next, implies, or if P then Q. In if P then Q, or P implies Q, what is the key point? So if first component true, second component false, then only false. The first component P is true, the second component Q is false, then only this P implies Q is false. So remaining cases, true. Remaining cases, true. So here you can remember in another way also. If the given statement is true, it doesn't imply false conclusion. So that means when P is true, Q cannot be false. That means this is not at all possible. That means it is an invalid statement. Invalid statement means what? It should be false. It never valid. Valid statement means true. A true statement is nothing but valid statement. A false statement is nothing but invalid statement. So here in P implies Q, how we can remember? First component true, second component false, then only false. Remaining cases true. And in biconditional. So how to remember biconditional? Key point, if both components P and Q have same truth values, same truth value means either both are true or both are false, then only this compound statement is true. this compound statement is true. Otherwise, false. So otherwise false in the sense what? If both components have opposite truth values, then only it is false. See here, if both are true, both are false, true. That means both are having same truth values, both components having same truth values, then the biconditional statement is true. Otherwise false. See, in these two cases, P and Q have opposite truth values, that is why here false. Next, obviously negation is nothing but opposite. Negation is nothing but opposite meaning of the given statement. So that means if the given statement is true, obviously its negation must be false. See here, if I said 2 plus 2 is 4 is the given statement, then its negation becomes what? 2 plus 2 not equal to 4. So 2 plus 2 is equal to 4 is always true. So 2 plus 2 not equal to 4 is obviously false. So that means whenever the given statement is true, its negation is false. And similarly, if the given statement is false, then its negation is true. So this is the important area. Okay. So if you learn these tables, so maximum you are getting, you can solve that one question. Because most of the problems in the JEE mains, they are asking the questions from this table or tautology contradiction or converse inverse contradiction. That is, I will explain next lecture. So first you observe the next, let me complete the last two definitions, tautology and contradiction. So when we say that a compound statement is a tautology, so a compound statement is said to be tautology if it is always true. If it is always true in any combination, So the tautology is denoted by T, the small symbol T. And contradiction, it is denoted by the small c or small f. So it is just a negation of tautology. So tautology what? Always true. Then contradiction, always false. That means when we say that a compound statement is a contradiction, if that compound statement is always false, it is always false in any combination, So the basic example for tautology is P or negation P, and in a basic example for contradiction is P and negation P. And remember, so P or negation P is always true. That is why it is a tautology. And P and negation P is always false. That is why it is contradiction. See here, P or negation P. See in R, what is the rule? If both are false, then only false. Suppose if P and negation P, is it possible both are false at a time? Not possible. So that means it never false. That means it is always true. Next, in AND, what is the rule? If both are true, both components are true, then only the compound statement P and Q is true. Here, P and negation P, whether they have, is it possible both are true at a time? No, never possible. So that's why it is always false. So that is P or negation P. It is nothing but, it is an example for a tautology. And P and negation P, it is an example for contradiction. So in the next lecture, I will discuss properties. Next, I will discuss converse, inverse, contrapositive and quantifiers for all there exist. And the negation of, how to find the negation of these 4 compound statements. Thank you.